Hi guys, how are you doing? This is Teacher Smile and today we are going to talk about limits. Okay, what exactly do we need to know about limits? I'm not going to talk much about what are they and things like that, like the other versions that we are not going to see in grade 12. If you need those ones, you can just send me a message. I can do that as a special video. But for now, let's just look at limits. Okay, so let's say we are given these situations. What would we do to solve them? So let's look at the solutions here. For A, we can easily see that if we plug in 0, there's nothing wrong with that. 2, 0 plus 1. So my answer is simply going to be 0 plus 1, which is equal to 1. Yes, you just plug in 0, just like that. Yes, easy. Then you come here, it's saying 3m. So wherever there's m, I'm plugging in 0. So that's y is equal to 3 times 0, and it's 0. Okay, easy. C, as k goes to 2, we are just saying y is equal to, what do you do? According to what we just said, plug in 2, right? 2 squared plus 2 over 2. Yes, what do you get now? That's 4 plus 2 over 2, and that's equal to 6 over 2, which is equal to 3. Easy. But let's say there was a d here, and d was y is equals to limit as k goes to 0 of k squared plus k all over k. Okay, here we plugged in 2, it was fine because we didn't have contradictions. But now, what would happen is if I am to plug in 0 the way it is, I'm going to get y is equal to, here I'm plugging in 0, I get 0 squared plus 0 over 0, of which in maths, we never want a situation when denominator is equal to 0. Denominator doesn't have to be 0, no matter what. So you try by all means to avoid this situation. Because once it happens like this, oh, that's bad. So we need to do something about it. What do we do? Before we start calculating, we have to think, is there a way to get around that? And of course, there is. What's that way? D, we have to write y is equal to limit as k goes to 0. Try to find a way try to find a way here to factorize the top so that maybe there will not be that denominator to cause this problem. So we have k, if we factor out, and we'll be left with k here plus 1, right, on the numerator, all over k. And when we cancel our k, we can now have limit as k goes to 0 of k plus 1. And we can now plug in 0, and we have 0 plus 1, and the answer is equal to 1. You can see what's happening here. This is what we do when we are dealing with limits. Okay, let's have a couple of examples again to help us understand. If it was E and we have y is equals to limit as k is equals to 3 of 1 over k plus 1. Yeah, no worries, just put 1 over 3 plus 1 is not a problem. So the answer is equals to 1 over 4. So, not a problem. If I am to deal with this limit, y is equals to, let's say, k squared minus 9 all over k minus 3. Oh, I left the limit. Limit as k goes to 3. The limit as k goes to 3. So what does that mean now? It means if I am to put this 3 everywhere, I'm going to have a problem because I'm going to have 3 squared minus 9 all over 3 minus 3. Okay? And in the denominator is going to be 0. And we don't want this situation. So we have to think about a way to get around this. And what could be the way? The way is we start by factorizing on top. This is difference of two squares. K minus 3, k plus 3. All over k minus 3. Oh, by the way, there's still limit. Hey, why am I forgetting limit here? Okay, so it's y is equals to limit as k goes to 3 of the numerator, we factorize it, that's k minus 3, k plus 3, all over k minus 3. So what's going to happen? K minus 3 and k minus 3 will cancel out. So we'll be left with the limit as k goes to 3 of k plus 3, right? And what do? Just substitute here, because if I substitute, there's no problem now. That's 3 plus 3, and the answer is equal to 6. That's what we do when we are dealing with the limits. So try to make sure that you understand everything about these limits, as they will be a lifesaver in calculus, in differentiation from first principles, grade 12. Thank you so much. I hope you understood. Don't forget to subscribe, and goodbye.